We are looking at chapter 2, the stacks and queues in list. What are queues? In normal life, at the bank or the fee counter or shopping center, you will encounter this queue. So this gentleman has come earlier than all these. He might have come last. Okay. So this is a kind of queue. And here is the ticket man. When he serves the first person, he is going to leave first. And this guy is going to leave last. And the other person, if he happens to come to this counter, he will be standing here. He will not be allowed to enter here or here. Right? So this is a queue. Queue is a very common data structure found in your computer algorithms, computer science, various scenario you'll see queue. And this particular queue is container of these elements where the insertion and removal are done in FIFO principle. Means first he might have come first, so first he will be out. First he will be out and then he will be out. So first in, first out. And the person who has come first, as he is relieved, this person becomes the first here. Right? And in the similar manner, when this he has come, he has to wait till all these are served. Queue, this is a data structure where first in, first come out is done, and there are two possible operations that can be done. First is the removal of elements from list. If we implement it using list or array, the removal can be done from the one end and the insertion can be done from the other end. We call it as the front, we call it as the rear. So the removal is only possible from front, and the insertion or addition or appending can only be done here. So this is first come first out or FIFO type of FIFO data structure. So what we are going to do here is, we'll see about this first, then rear, and these two are our end for insertion and deletion. There are various applications of queue. That is why it becomes so important. In a single processor, multitasking computer, job waiting to be processed form a queue. So whenever there is a, say, process, so we have long-term scheduler and short-term scheduler. They does exactly that. They place the item in queue. So first, whichever has come, then they are being processed first. So you have all that round robin, and there are a number of short task first. All these scheduling there are, but the basic thing is they are placed in the queue. Then if you compile high-level language, then also queue is formed. In a download manager, the multiple files also uses queue for ordering the file. In a multi-user OS, job scheduling is done through queue. The queue operations, as I said, there are two operations which are possible mostly in your queue. First is your removal, and removal can be done from the front only, or the addition can only be done on rear. So first you can first operation is to create a queue. So we can store elements in order, insertion of an element at rear, and deletion of element here from the front. So let us understand this with the help of an example. If you say you have an array or a list, then this is how it is right now. It is empty. So now when it is empty, even if it is an array or a list, then there is no element. So front will point to what? -1, and rear also -1, because if for front and rear points to 0, then we see that as array and list are described, 0 index means one element is there. Because there is no element, the front and rear should be pointing to -1 or should have value -1. Next thing is, let us add or append the value 5. So this will be added where? At the rear. So now the front, because front has nothing, so front will be also the first one, rear will also be the first one. So for front and rear will point to the same element. Now second is, let us add one more element, 15. So rear is going to point here. So rear is going to be added or it will be incremented. Now you want to delete this 5, so it will be decremented from the or relieved from the front. So 5 will be relieved or deleted. Now this 5, the F has to point to this 15. So now again the front and rear are the same because there is only one element. Now you want to add 25. When you add 25 here, then you have to because adding can only be done at the rear. So rear has to be incremented. So rear has to be incremented. Then again you want to add 35. So 35 is added. So rear now points to 35 like this. Rear will be pointing here. And then you want to delete. So 15 will be deleted. F will point now to 25. And if you want to delete again, F is going to point again to 35. So this is how insertion and deletion is being done. There are situations which we need to understand that, first of all, if the queue is empty, will you be able to delete anything? No. If you want to delete an element from an array or a list, and this list or array contains no element, this is called the underflow condition. If you have an array or a list, if you go to C, C++, Java, etc., then the array has to be fixed. But in Python, etc., the dynamically typed language, where list a form of array only, it can be extended, or the size is not fixed, it can be extended. So whenever you want to add one more element in an array, and if this array is full, then you will encounter what? You will encounter overflow, because there is no place you can add. But in languages like Python, we don't have to deal with this overflow, because the list, we are dealing with list, so it can be extended. But we have to deal with the underflow condition. So what is the algorithm? How can we insert an element? We'll start. Check for front and rear value. If they both are -1, we say that this is insertion. That means we have no element. So front, we will first increment the F and R of front or this rear with 1. Then we'll add the element to the rear. So new element will be added to the rear point on the back. The algorithm for deletion is, you have a list you want to delete. Now you have to check whether this list at all has an element or not. If it has no element, you will not be able to delete. So that will be a condition which we call as underflow. So we have to check for underflow condition if front equal to -1, and you have to appropriately show the message. Then what you have to do is, you can delete the item from the front, and then if you can delete it if front equal to rear, then front rear equal to -1, otherwise you just increment by 1. Front you have to increase because you have added an element or deleted an element. If you have deleted an element, you have to increase the front because this part is now done. So this is how item is being deleted, right? And the basic thing is, in languages like Python, there are already inbuilt function for that. If you want to traverse, you just have to see that whether F or the front is -1 or not. If front is -1, there is no element, queue is empty. Otherwise, we just have to use a for or while loop, and you can traverse F till you go to the rear. Okay, rear point. So we have already del and append functions in Python that deal with this. So front and rear, they are already being employed and being implemented in Python, so you don't have to worry about that. Let us see the program to implement queue using list, but here we are going to do without the class, and we'll also see with class. So how to implement a queue? You can just make an empty list, Then you say C equal to Y, because first of all, when you run this code, you want to show these to the user. Print, these are the options being shown to the user. Insert, delete, display. Then enter your choice. User will enter either insert, delete or display. 1. If choice is 1, new value will be appended. So A, this one, dot append B. So this B will be appended to this A. If choice is 2, first you will check whether A is empty or not. If it is empty, we say Q is empty. Otherwise, you delete the item A0. You'd have to just say delete del A0. If choice is 3, you want to display it, you will just check the length of A and do a for loop from I to this length and print AI. And otherwise, if user does not put 1, 2 or 3, you will say it is a wrong input. And then you will ask user whether you want to continue or not. If he presses yes, it will go. Otherwise, any other character then Y will stop this program. This is a program of implementing Q using class. So we can use a class called Q. You can make a Q, that is an empty list. You can implement insertion, deletion and display function. In insertion, you will ask for an element and you will just append in this class Q.append, and this A will be appended. Deletion, you will check for whether it is empty or not, because you have to check for the underflow condition. Otherwise, you will simply delete Q.Q0. So this will be deleted. And then you want to display, so you have to find out the length of this Q, and then you can just from I to range, means all the elements you are going to print. Then you will make an object A, say C equal to Y, because while C equal to Y, user will be shown insertion, deletion, display. User is going to input the choice. 1 is for insertion, 2 is for deletion, and 3 for display. These 3 functions, 1, 2, 3 are going to be called. If any input other than 1, 2, 3, you will say wrong input. And then you will ask you want to continue. If user wants to continue, he'll press yes. Again, this while will run, otherwise it will come out. So what we have learned today is that LIFO, last in first out, FIFO, first in first out. Stack is a container of elements that are inserted and removed according to the last in first out at one and only. Q is a container of element which the element are inserted on the rear and deleted from the front. Infix, it follows the FIFO law. There are expressions, 3 type of mainly expression. Infix, operator is between the operand. Postfix expression, operators are written after the operand. And prefix operation, operators are written before operand. So thank you so much. This was about the stacks and queues.